With the increasingly complex electrical systems being used in vehicles today, it's more important than ever to keep up with the new equipment and procedures so you can better resolve customers' problems. Hi, and welcome to this month's VideoTec. In this program, we'll give you an update on Jeep and Eagle electrical systems. We'll start out with a look at some new features for Jeep vehicles. We'll then move on to a look at some concerns with Talon, including some tips you can use now to prevent possible problems in the future. Let's start our look at Jeep Changes with the electronic cluster that's new for the '92 Wrangler. You may remember that we touched on this new cluster in the September VideoTec where we discussed new model features. The new electronic cluster's speedometer allows for more accurate reading, especially at lower speeds. Another big improvement over a cable-operated speedometer is that the electronic one is much quieter. Now, no more cable noise complaints. The gauges are also now easier to read at night due to a new backlighting technology that's very effective at carrying light through the gauges. Another advantage of this cluster is a more accurate fuel gauge. This new gauge has increased viscous dampening that mechanically averages the fuel level. This helps eliminate the effects of fuel slosh. The four-wheel drive indicator, or telltale, has been relocated from above the steering column to the gauge package. This cluster also has fewer connectors coming into it. In fact, the number has been reduced from 5 connectors to just 1 pin header connector. This pin header connector allows increased reliability and also helps reduce the clutter of all those extra connectors. This reduced number of connectors also makes it easier to remove the cluster. To remove the cluster, first remove the 6 shroud screws and then remove the shroud pieces. Next, remove the 3 screws holding the right side switch panel. And then do the same for the left side. Next, remove the 2 upper screws to gain access to the pin header connector for its removal. The connector is located behind the tachometer. Once this is disconnected, the cluster can be removed. Naturally, with this cluster's new speedometer comes a new odometer. An interesting point about this new odometer is that when it needs to be replaced, it is sent to the service center to be exchanged for a new one that has the correct mileage electronically set. That means it's no longer necessary to have a door jamb sticker or a red 1/10 of a mile wheel that tells of a repair. The electronic speedometer and odometer use signals from a new distance sensor. This new sensor is a Hall effect switch, and like the old sensor, it's mounted in the transfer case. This sensor is mounted to a pickup plate. The shutter blade rotates, causing the voltage to change from 8 volts to 0 volts. This on-off switching causes a signal pulse that is sent to the speedometer. The faster the vehicle is traveling, the faster the pulses. As mentioned earlier, this new instrument cluster has many features to make it more accurate and reliable. But if a problem with the speedometer or tachometer develops, the service manual diagnosis procedure will help you find the problem in no time. To diagnose the speedometer, first disconnect the distance sensor connector and connect a voltmeter between the connector pin of the white wire with a black tracer and ground. Next, turn the ignition to the run position and check for approximately 8 volts. If the voltmeter reads less than 7 volts, check for continuity between the distance sensor and terminal 13 of the instrument cluster. If there is continuity, replace the speedometer. If there is not continuity, then repair the open circuit. If when checking the distance sensor voltage you get approximately 8 volts, then use the DRB2 to diagnose the sensor. To do this, hook up the DRB2, and when you get to the Select System menu, choose Engine. Next, enter the air conditioning information, and when you get to the Engine System menu, choose Fuel Ignition. At this point, choose State Display. Under the Fuel Ignition State menu, choose Sensors. Scroll down to where the car speed appears. Now, Take the DRB2 for a short ride and see if it reads out the vehicle speed. If the DRB2 shows speed, then the distance sensor is okay. If it doesn't show speed, then replace the sensor. The sensor can also be diagnosed through the vehicle's onboard diagnostics by cycling the key 3 times and reading the engine lamp flashes. The onboard diagnostics are helpful, but you'll get a better picture of what's wrong with the vehicle by using the DRB2. Something else you want to remember is that if the distance sensor is not functioning properly, the Mopar add-on speed control, if equipped, will be affected. If the tachometer isn't working, it'll help to know how the tachometer interacts with the engine controller so you'll understand better how to diagnose it. Since the vehicle is running, the engine speed sensor is sending out engine speed signals to the engine controller. If it wasn't, the engine would not run. Therefore, focus your investigation on the circuit between the engine controller pin 43 and the tachometer. Check for continuity between cluster pin 12 and engine controller pin 43. If there is continuity between cluster pin 12 and engine controller pin 43, replace the tachometer. If there is no continuity, repair the open circuit. While we were taking a look at the new Wrangler cluster, you may have noticed that the clock is no longer there. That's because the clock is now part of the radio. If you have any questions about setting clocks, consult the vehicle's owner's manual. Now we'll move on to another feature of the 92 Jeeps, a new heated backlight relay. For the Wrangler, the new relay is in the same location as in the 91 Wrangler, which is on the driver's side kick panel. The new relay is red. On the 91 Cherokee, you may remember that the heated backlight relay was behind the instrument panel to the left of the steering column. The new relay is still behind the instrument panel, but on the right of the steering column. Now for a bigger change. If you'll remember back to the March 91 VideoTec program, we told you that the vehicle theft security system for the Cherokee was similar to other Chrysler Corporation alarms, except that it could not be diagnosed by the DRB2. Well, now it can. As you may also remember, the network that the security alarm module and the engine controller communicated with each other on was known as the C2D Bus. This communication network is now also diagnosable by the DRB2. What is the C2D Bus? Well, it stands for Chrysler Collision Detection System. In this case, collision refers to the collision of data along the communication links. The information is passed between C2D chips that are inside each controller in the system. The twisted wires that the data passes over are known as the bus. Each controller is wired in parallel so that all controllers on the bus can receive all the messages that are broadcast, so long as they are designed to accept them. On a Cherokee, the Security Alarm Module, or SAM, is a send-only controller, which means it cannot receive messages, only broadcast them. The engine controller, however, is a send and receive controller. There are only 3 controllers in the Cherokee C2D bus system. These are the engine controller, the SAM, and now the anti-lock brake module. This type of system, however, can operate with many more controllers. Because of the possibility of a great deal of information traveling through the system at the same time, each message is ranked by a priority code so that the more important messages go first. The bus wires that carry the messages are twisted together. This is done to shield the wires from magnetic interference, which could cause false messages. The proper twist specification is 1 turn for each 1 3/4 inches of travel. The voltage supplied to these 2 wires is about 2.5 volts for each wire. Actually, the bus minus wire is about 2.51 volts, and the bus plus wire is about 2.49 volts. This voltage that is required to operate the bus is called the bus bias. The process of obtaining the bias voltage starts with a 5-volt supply going through a 13,000 ohm resistor, which drops the voltage to about 2.51 volts on bus minus. The current then flows through a 120 ohm termination resistor, which causes a voltage drop of about 0.02 of a volt to bus plus. This termination resistor completes the circuit from bus minus to bus plus. The current then flows through another 13,000 ohm resistor to ground to complete the circuit. While we're on the subject of the voltage required to operate the bus, the minimum bus bias operating voltage is 1.5 volts, and the maximum operating voltage is 3.5 volts. Inside this range is where signal clarity is optimal. If voltage goes outside this range, the controllers will have difficulty interpreting the message. Well, that's enough background information on the C2D bus. This information will be useful to fully understand what's happening when diagnosing the security system, because the C2D bus is tested before you access specific security system information. If you were going to use the DRB2 to diagnose the security system, first you will need to hook it up at the diagnostic connector under the instrument panel. Here are the bus plus and bus minus terminals of the diagnostic connector. These are the wires the DRB2 communicates on. With the DRB2 hooked up, turn the ignition key on. When you get to the first menu, choose Select System. Since we are trying to get to the security system's screens, we'll choose Theft Alarm. The C2D bus is then automatically tested. During the self-test procedure, the DRB2 checks for 11 different failures. If none of these failures is present, then the screen will display bus operational. If, however, there is a failure, a fault message will appear on the DRB2 and the bus will not be operational. The bus fault messages will fall into 3 categories: bus bias messages, bus termination messages, and wire fault messages. The bus bias messages are bus bias level too low, bus bias level too high, and no bus bias. The only bus termination message is no bus termination. The wire fault messages are more numerous. They include bus plus and bus minus open, bus minus open, bus plus open, bus plus and bus minus shorted together, short to ground, short to 5 volts, and short to battery. If the fault message is due to a short in the system, the red light on the DRB2 will glow and you will not be able to access any further tests. If any of the other bus fault messages are displayed, the red light will be lit, but since the wires are not shorted, you may access the next level of testing by pressing the mode and enter keys on the DRB2 at the same time. Once you've used these keys to bypass the fault message, the next step is to test the engine controller, the anti-lock brake module, and the SAM to determine which one is not talking on the bus. If this were the case, you would get a no response message from the controller. Again, if there are no problems with the C2D bus, the DRB2 will read bus operational, and then the module ID will appear. This is important diagnostic information that we'll discuss in just a few minutes. After the module ID, the theft alarm menu will appear. To read the status of the inputs and outputs in the theft alarm system, first choose State Display, and the theft alarm state menu will appear. At this point, choose Inputs, Outputs, and then choose which one of those two you want. By choosing inputs, you can check the inputs like the ignition switch, the door switches, and the power lock switches. This will help you check the status of the input. If you choose the outputs display, you'll be told the status of the horns and lamps that are used to signal whether the theft alarm has been activated. By going back to the theft alarm state menu and choosing monitors, you can determine whether the theft alarm is armed, whether the horns and lights are timed out, or whether it's okay to arm the alarm or run the engine. Also under monitors, you'll be able to see what last triggered the alarm. This option is available on security alarm modules 5.0 and later. This is why we told you the module ID screen that's displayed on the DRB2 was important. That is how you know what module you have. To perform actuator tests, you'll need to go back to the theft alarm menu and choose Actuator Tests. To test the horn, choose Horn, and the DRB2 will test it. If you were to choose Park Tail Lamps from the Actuator Test menu, the DRB2 would perform a similar test for the park and tail lamps. Along with these major changes to the vehicle theft security system on the Cherokee, another minor change has been made to the wiring from the security alarm module. On the 92 Cherokee's security alarm system, both of the SAM's ignition wires coming from the ignition switch no longer go through the same fuse on their way to the SAM. Now, the wire from terminal 6 goes through the 10 amp clock accessory fuse, and the wire from terminal 19 goes through the windshield wiper circuit breaker. Another minor change to Jeep vehicles is the use of a new chime module. This new module performs the same functions and is in the same place as the old one. There are also some minor changes to the wiring of the module. The module wiring is basically the same between the Cherokee Comanche vehicles and the Wrangler. You may have noticed that the Wrangler does not have a headlamp reminder, as does the Cherokee and Comanche. Now, another major change for Jeep vehicles. As with the security system on the Cherokee and the distance sensor on the Wrangler, you can now use the DRB2 to diagnose problems with the new computer-controlled charging system on Jeep vehicles. This was a change that started in the 91 model year. The voltage regulator is no longer inside the alternator. The voltage regulator function is now managed by the engine controller. The engine controller keeps the charging system voltage between 12.9 and 15 volts. The exact amount of voltage needed at any given time is known as the voltage goal. The voltage goal is calculated by the engine controller based on information from three sources: the battery voltage sense, the battery temperature sensor, and the engine controller's own program. The voltage sense is the value that tells the engine controller what electrical load the battery is under and what the battery's state of charge is. The battery temperature sensor, located in the engine controller, determines the battery's temperature. Again, both the battery temperature and the voltage sense are used, along with the engine controller's own program, to calculate the voltage goal. Once this goal is set, the battery sense is compared to it, and the alternator output is adjusted by grounding the alternator field when more voltage is needed and opening the field when the voltage output is too high. Because all of these functions are regulated by the engine controller, charging system information can be accessed by the DRB2. To use the DRB2 with the charging system, connect it to the diagnostic connector by the engine controller. When you get to the Select System menu, choose Engine, and then enter whether the vehicle has air conditioning. At the Engine System menu, choose Charging. If you want to read the charging system faults, choose Read Faults. This will display any charging system faults that have been recorded. If you want to see how the charging system is performing, then go back to the Charging menu and choose State Display. By doing this, two informative screens can be called up. These screens are accessed by choosing either Sensors or Monitors. When Sensors is chosen, the voltage sense, the voltage goal, the battery temperature, and engine RPM can be read. By choosing Monitors, basically the same information is displayed in a slightly different format. As with many other applications of the DRB2, there is an Actuator Tests selection. This can be found back on the Charging menu. By choosing Alt Field, you can test the alternator field. Or by choosing Engine RPM, you can set the engine speed at the desired level. This can be useful, for example, when testing the battery. Another new feature of Jeep electrical systems is the replacement of the ignition off-draw, or IOD connector, with a fuse in the power distribution center. This fuse serves the same purpose as the connector, namely not allowing such components as the clock, engine controller, and the like to drain electricity from the battery during shipment or storage. When you're prepping the vehicle for delivery, locate the fuse in the power distribution center's cover and place it in the location marked on the cover as the IOD circuits. Remember, after the ignition off-draw fuse has been inserted, the clock will need to be reprogrammed. The Talon also has a change in its IOD system. The Talon did have a fuse for this protection, much like the Jeep's new system, but now it has a connector. The new connector is in the relay box in the engine compartment. Vehicles are shipped with the IOD connector in the disconnect position. To connect the IOD connector, turn the ignition switch to the off position and remove the key. Go to the engine compartment and remove the relay box cover. The IOD connector is yellow. To connect it, simply push down. When you're finished, reinstall the relay box cover. While we're on the subject of the new Talon, no doubt you've already noticed the most obvious change for 92, the headlights. The new Aero headlights no longer use the replaceable sealed beam retractable headlight. Instead, the 92 Talon headlights have a replaceable halogen bulb. As you may recall from September's VideoTec, the bulbs are accessed from the sockets behind the headlights. Again, it bears mentioning that you should be careful not to touch the bulb with your skin or dirty gloves, because this can seriously affect bulb life. Also, when replacing a bulb, securely install the cap. Failure to do so may cause moisture to enter the headlight assembly, reducing the light's effectiveness. Of course, these new headlights also mean a new headlight aiming procedure. When aiming the vertical angle of the headlights, it's no longer necessary to attach headlight aimers containing bubble levels to the headlight. For 92, the bubble levels are built right into the headlight assembly. The pre-aiming procedure is the same as last year. Once these instructions are completed, adjust the vertical angle first. To do this, insert a screwdriver into the vertical adjusting hole here and turn clockwise or counterclockwise to bring the bubble of the vertical angle gauge to the center. For every mark, the beam angle will change about 0 degrees 19 minutes. When this is complete, adjust the horizontal angle by pulling the stopper upward so you can press the large gear forward. This will disengage it from the small gear, enabling you to insert a screwdriver into the horizontal adjusting hole. The angle can now be adjusted with the headlight tester. Here, every mark equals about 0 degrees 36 minutes. When using the headlight tester to adjust the horizontal angle of the headlight, be sure to follow the steps in the tester instruction booklet. When the correct angle has been reached, align the 0 mark on the large gear with the center line on the stopper and press the stopper down to lock it. Another important concern with the Talon deals with the 91 DRB2 cartridge. When checking the wheel speed sensors on the Talon's anti-lock brake system, keep in mind that the left front and the right front wheel speed sensor readouts are reversed. This, of course, means that when the DRB2 says there's a problem with the right front wheel speed sensor, it's actually the left front sensor that should be investigated. The 92-91 cartridge reads out the proper wheel speed sensor, so you should make a habit of using that cartridge when working on 91 Talons equipped with ABS. Since we're talking about the DRB2, here's another useful tip on its use. When using the DRB2, you may have a fault code set for a component that appears to be good. The problem might not be the component itself, but rather a mechanical problem that is setting the fault code. For example, let's take a look at a problem where the DRB2 reads that the airflow sensor on a Talon is not working properly. If the sensor is known to be good and the fault is still being set, it may be a mechanical problem causing the fault. So we inspect the area around the airflow sensor for anything that may cause the fault to be set. In our example, upon inspection, an unfastened air cleaner housing was found. So after fastening the housing, we go back to the DRB2 and check for the fault again. First, we clear the previous fault message and then check to see if it reappears. In this case, the air cleaner housing was the problem after all. This shows the importance of making a visual inspection when a problem develops. Next, we're going to discuss some measures to keep in mind to prevent future electrical problems. The first is about cavity numbering on electrical connectors. Remember to always check the circuit diagrams for the proper numbering. If the connector itself has what appears to be cavity numbering written on it, ignore it. These numbers are for production only and should not be followed. When looking at connector terminal numbering in a wiring diagram, establish whether you're looking at the male or female connector. The male end of the connector is framed by a double line, while the female connector is framed by a single line. While we have the electrical service manual for the Talon out, we're going to watch our technician do something very important, keeping the service manual updated. Whenever there's a service manual change that necessitates the technical service bulletin, do as the cover page of the TSB suggests and make changes to the service manual. Doing so puts the information where it is most visible. In this case, the technician is adding some updated circuit diagrams to the Talon electrical service manual. The TSB number is 265191. Section 26, the section that this is filed under, is the miscellaneous section, not the electrical section as you might think, which is Section 8. Remembering some of these tips will help avert future problems with the electrical components you're working on. To learn even more about Jeep and Eagle electrical systems, attend a training course at your nearest Chrysler Corporation Training Center. Look in your technical training course selection guide under Skilled Category 2, where you'll find courses on such subjects as basic electrical systems, starting and charging systems, and even a current year DRB2 update. Well, that about does it for this month. We'll see you next month when we talk about anti-lock brakes for both the Talon and the Summit. We'll be here, so make sure you are too.